most of all, thank you to you guys, because it's really about you, the community, and thanks for showing up today and coming along. It's always nice to see some new faces and some familiar ones. So, yeah, thanks a lot. Over to you, Alex.
Thanks. Definitely, thanks for coming, guys. Quite a crowd. But anyway, Andrew Powell couldn't make it, but big shout out to him. He done a presentation just a few weeks back about what was it called? Magical burnout chart.
Yes.
And it was big inspiration for me, and I thought, okay, how we do the same thing, exactly the same thing what he presented. And if you miss it, there might be some recordings, so yeah, you can look it up. But take off all the magic and just do math, pure math, right? So it's all about two questions. How long will it take us to deliver a feature, right? Or, second question, how much we can do in a period of time. Yeah? So let's say usually people ask, can you build this by the Christmas? And you say yes or no, right? Or people say, okay, next 4 months, 2 months, how much you can deliver as a software team or pretty much any team working on tasks, right? And that's, I'm not sure if you all from software background, I'm from software, but this is kind of general, very general thing. And people obviously estimate and do all different things and have huge planning meetings and try to put a lot of that magic into estimations. But there's a sort of mathematical way to do it. And it's quite simple, but math involved, right? So there'll be statistics, and I want to go through this. It might be kind of hard. It's hard for me. But when we get through this, I think it's going to be good. It's going to be worth it at the end. And we're going to have a bit of a discussion after. But I'm kind of easily confused. I'll try to explain. I'll do my best, and I will ask for questions. Right? Just try not to sort of ask questions. People interrupt me, and I will go off. Okay, so Monte Carlo analysis, right? It's just a statistical method. And if you're interested, you can Google it and you'll find it. But it has very practical use for project estimations, right? First, we need to understand what's the normal distribution from statistics, right? Bell curve. We all know, like you're supposed to know, I guess, bell curve. What does it mean? It means things in certain range and they are more predictable. Let's say adult height, right? So people usually go from what it says like 150 to like 2 meters high, right? And average would be here somewhere, and it's going to be like 175, right? So this is normal distribution. We can say average person, adult person, 175. There are no one like 10 meters tall, right? Nobody. We can guarantee it. This is normally distributed for a population, I guess. Comparing to, let's say, wealth distribution, right? If you look at the wealth, human wealth, it's going to go like that, right? There'll be like Elon Musk here somewhere. There'll be like Bill Gates, right? There'll be us like here somewhere. But then like billions of people over there, right? And it's called like a long tail distribution, right? So there is no limit. Like Elon Musk can go way up. Nothing limits it. So what difference between normal, we can say, okay, average is 175. It doesn't make sense to talk about average or mean in this case. So you need to understand what distribution you're in, because Monte Carlo only works on normal distributed sets, right? I can tell you like a joke about this one. When Bill Gates walks in the bar, everyone in the bar, a millionaire on average, right? It doesn't make sense. Yeah? So first, before we start, you need to make sure you're in normal world, normally distributed, right? And that's what usually happens with projects. Like you don't go right in stratosphere with your delivery, right? You normally like go week by week, roughly the same amount of. And we talk about like work items or user stories or whatever. But let's say work items, right? You deliver, and we look at some period, right, to estimate. And in Agile they go by Scrum, sprints, right, or you can go by day, depending on how many users, how many work items you deliver, and how you build your set. I usually go by week, like week by week, and I say, well, every week we deliver roughly like 10 work items as a software delivery team, and that's what we use to estimate, right? And I can say, okay, in 4 weeks we deliver so much, by Christmas we deliver so much, right? Monte Carlo based on history, historical data. First, we need to collect some history, and obviously, more history you have, more accurate it's going to be. But even like I usually, that's why I use weeks, because like you have 10, 20 weeks, it's pretty good enough. It's already good enough, right? If you go by sprints, to get 10 sprints, it's quite a big time takes to take to get to 10 sprints. And also, Monte Carlo predicts based on your historical history if nothing's going to change, right? If trend continues as it is now, that's what you get out of Monte Carlo. If you go for 10 sprints, most likely something's going to change. You know, you get new people, you get new projects, something's going to change. So your trend is not as clear because the history is quite long. All right. Anyway, I'll just give you an example. So let's say that's our data sample. We go week 1, we delivered like 7 work items, and then whatever 8. Week 3, we numbers at 10, right? Something like that. Week 4, 12, and we go on, right? How many you have? Doesn't matter. Now we know this is normally distributed set of data. You know, let's start with this assumption. If not, then stop. Nothing's going to work. So we know all these numbers, they belong on this bell curve, right? So we can build the bell curve based on these numbers. And to build it, you need 2 parameters. You need your mean, average, and you need your standard deviation. Standard deviation, also called variance. So to get average, you just average whatever you have, history, right? And let's say you have 10, which means on average you deliver 10 work items per week. To get standard deviation, you need to put your numbers in any spreadsheet, Excel, Google Sheets, anything, and there'll be like a function, give me standard deviation. And whatever, I don't know what standard deviation, maybe I don't know. Oh yeah, it's going to be 8, right? Okay, so when, based on these 2 numbers, like statistical software can build you bell curve. So there's going to be 10 here, right? And 8 depends on this number. It depends how wide your bell curve is going to be. Like smaller this number, smaller variance is going to be more narrow, and wider it is, it means you're not consistent. You're all over the place with your delivery, right? And bigger the variance, so the less certainty you're going to have in outcomes. It kind of makes sense, right? If you consistently do 10 every week, then it's quite consistent. You can rely on that. But if you do like 50, 100, and then 10 and 5, you know, it's not going to work that well. So we get historical data, we get these 2 numbers, we build the bell curve. Now we're ready to do Monte Carlo simulations. And simulation, that's what it is, simulation. Yep. And you say, okay, let's try. Okay, question. First question was, how many work items can you complete in 4 weeks, right? So 4 weeks. That's our question, comes from the boss. Say, how many work items would you complete in 4 weeks based on that historical data? And you say, okay, like roughly it's going to be around 40, but Monte Carlo is going to give better answer. So what we do, we need to emulate, like simulate 4 weeks of work. And we just randomly, like blindly hit that bell curve, because all our possible work items are going to be on this bell curve. So we're going to get this. Let's say this is 5, and this would be like 15, right? So we hit it. It's okay. It's going to be 5, and then it's going to be bang like 12, then it's going to be some here, 8. It's going to be whatever, any numbers, right? 1. Doesn't matter. 4 weeks. Right? That's one round. How many would we do? That's going to be 26. Week 1, one try, we deliver 26 work items. Okay, let's go second one. And we hit whatever. 6, and we hit 18, whatever, 14, and let's go 12. It's a good week. So we got like 30 and another 20. We got 50, right? And you keep doing that. Talk some random numbers, you're just hitting them. And you obviously need some software to generate random numbers. And you do it about 10,000 times, at least. More you do, more accurate your result. But 10,000 is enough. After that, you're going to waste your milliseconds on calculations. Like under 3,000, you're not going to get a good result. Again, but it depends on your variance as well, right? So anyway, we got all these numbers, right? Whatever. 10,000 simulations of the results of 4 weeks of work based on our history. We sort them in order, from smallest to like highest, and I think it will start from 0, right? There'll be 1, extreme case, and go pretty quickly 2, like 10, whatever, blah blah blah, and it'll be like hundreds here, I don't know. And this is going to be bell curve as well. So it's going to be bell curve like that. And you can build it, but you don't need to. Like, you don't really need graph at all. All you need is just numbers. So you put your history in a spreadsheet, you get these 2, and then you use some software, hopefully software, right? To generate these random numbers, and you get your array of numbers, and you sort them. And then the biggest question is going to be, when someone asks, how many work items can you deliver in 4 weeks? What you need to say is, what certainty? What certainty do you want? It's not 100% or nothing. It's not yes or no. It's going to be percentage. And if we say, I want 50% certainty, that's going to be this. 4 weeks, it's going to be 40, right? And that's how you can check everything works. So when you sort this out, this array, 50%, I should put it somewhere. It's going to be line 5,000, right? You following? Because we run 10,000 simulations, 50% of results going to be up of the line of 5,000, right? So whatever number is here, and it should be 40 or something close to 40. It's not going to be exactly because of the number of runs, right? You need the infinite number of runs to get exactly 40. Yeah? But that's your checkpoint. So this is easy. Now, let's say we want 75% confidence. And you go to line, whatever, 7, 5. And whatever number is here, it's going to be less than 40, right? Okay, I'll put it, always make this mistake. You go other way around, yeah. So, 25, right? Doesn't work well. Let's do it again. So we got this 10,000 rows results, and 50% is going to be 5,000. That's 50%, right? So 75% is going to be here somewhere, and it's going to be 5, and this is supposed to be 40, so this will be 30 or so. Kind of makes sense if somebody asks, would you deliver it? You say, okay, yeah, how many work items? You say 40. Are you sure? You say, well, 30 for sure. Like higher your certainty, you less you give yourself well. Right? So because I changed the graph to results, right? It's not going to be, so it's going to be 40 here, and it's going to be like, I don't know, maybe 10 somewhere here, and then it would be like, I don't know, 8, whatever. So what it means, 75, you like draw a line like that, right? So what we can say, with probability of 75%, we deliver at least 30 work items in 4 weeks. That's the answer. Yeah? That's all. And then you go, okay, 90%. Yeah, it's going to be even less, right? And 90% is going to be wherever. You look at the line 1,000, and it's going to be a 90% probability, and it's going to be like 10 or something like that. Right? It goes very steep at the start, because 90 and 95% is going to be a huge difference. And like 50 and 75, not so much. Yeah? And that's why when you look at this probability of cloud SLAs, 0.999999, it costs them a lot of money every night. Yeah? Because you need to put a lot of effort to sort of like this stage, but then when you talk about 50, 60, 75, they might be the same answer. Yeah? So second question, exactly the same. And second question was, how many weeks would it take you to complete that 40 items? So we are given, we need to hit 40 items, right? 40 items, work items. And then we go our simulations, right? First run, we hit this bell curve, and say, week 1, we completed 5, week 2, we completed 6, and then we completed 12, and then we completed blah, 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 until we hit 40, right? How many weeks? 10, can you count? Do I need more? 43? Okay, so we hit 40. That's 43, and it's 1, 2, 3, 4, 5 weeks. 5 weeks. right? And run 2, it's going to be whatever, 12, 15, I don't know, 20, it doesn't matter. Because you hit sometimes these outliers, but it's going to be rare. Most of the time you're going to hit randomly this middle. Yeah, because that's the most of your values of this bucket, right? So that's 20, almost, yeah. Okay. That's going to be 1, 2, 3, 4 weeks. And again, you go to 10,000, and then you get this 5 weeks, 4 weeks. You build your array of weeks, and I don't know. Maybe you start with 1 week, but you quickly go to 2 weeks, and then like maybe 2 again, and 3, and 4, yeah. And it's going to bell curve. And exactly the same thing. You look at your certainty you want to achieve, but then it goes other way around. So you pick your row according to your certainty, and you get the answer straight away. Any questions on this? Purely mathematical, statistical questions. We all understand, right? Yeah, so I think that's the worst part of it, and now it's going to get maybe more interesting. So these answers you're going to get, they precise, they exact, they correct. There is no magic, there is no thinking, there is nothing. And you get them for free. Because when you build this little software, I have like working, right? It's like half a day of work of a developer. And you can get your answers right away. You just put your historical data, you collect your history, and like what I did at my job, we run it weekly. On Monday, I just hit button, I get the answer, right? So we're coming to Christmas, let's say, and the boss wants this feature delivered by Christmas. Like every week, we rerun, and we get closer and closer with our estimations. Right? We get more precise because we collect more historical data, but also that cone of uncertainty. Right? Further you go, more further like ahead you look, there's going to be more variance in your results. Right? So they converge.
What happens if you have a trend like the code's bad? So as you're going through your sprints, it's taking longer and longer and longer.
Yeah. It only predicts on your history, assuming nothing's going to change, right? So if this is Easter week, people on leave, it's not going to be your typical normally distributed kind of week. I would take it out of sample. You don't need to, because we're talking about normal, typical weeks of work. If something happened where you like had a big event or people got sick and it's out of, you know it's a normal event, that particularly, you just take it out. Yeah? Out of your sample size, out of history. Yeah? And if something's going to change in the future, you have to adjust because it only knows what happened. And you know you're going to get new people coming in big team and it's going to be changed, it's going to be reorg, there'll be something else. It's not going to work. It's going to be Christmas week. It's not going to work. You're not going to predict your Christmas break, right? So we need to be on the bell curve. Always remember that only works for normally distributed situation. Yeah?
You were talking about the average. It's all based on what items, right? Not story points. Nothing.
You can use story points, but then you put magic into it.
Yeah, exactly.
Yeah.
That's what I was thinking, yeah. So again, like coming back to the work item, each work item will be different. How do you?
Okay.
There's still little.
Are they normally distributed? Like usually when you try to break down your user stories, you go to small as possible, right?
Right.
So that's you're trying to make them as small as possible, but then on average amount of like extra large or extra small, they kind of normally distributed. That's what I found. If you go back to your history and look at how many user stories you delivered every sprint, it's going to be good enough. You don't need to like use story points, but you can. Instead of all this, yeah, you can build on average story points delivered and standard deviation, and yeah, you'll get your story points. It doesn't matter.
You just use tasks.
Or tasks, whatever you have. Yeah. Yeah. So, like I said, perfectly valid, absolutely correct, totally useless. Because the only use of it, this question, when someone asks, would you deliver this for Christmas? They want to hear yes or no. You're supposed to say, what's the certainty you want? And when you ask for certainty, they go, I don't know. Between 90 and 95, huge difference, massive. For humans, we don't work like that. We can't use statistics. Yeah? We use feelings. Would you deliver this by Christmas? Yes. Good. I feel good. No, bad. Yeah? That's the human approach. But people gonna ask you, right? And that's your answer. Tell me your certainty, right? What certainty you want? It's not gonna be 100%. Well, what it is. Right? And another good point, it's free. You build it, you run it, someone asks you a question, you're gonna get that's the answer. By Christmas, okay, 67.5% probability we're gonna deliver you this thing by Christmas. Okay. But it's free. And now they say, no, estimate it. Like put effort, put a team together in for 2 days. Okay, now you wanna spend all this money and resources, you need to prove that you can do better than this. Can you do better? No. Can you people somehow look at your crystal ball and do whatever, dancing and around and come up to the better answer? That's what I find useful. It's not hard to do, but then, and people understand when you talk to your boss or your manager or whatever, they understand what you're talking about when you ask for probability, for certainty. It's kind of, common sense. Questions so far? Cool. Wow, awesome. I forgot the book, but they say I want to keep sort of talking about this estimations and everything. They say the best business strategy. Let's go on. Don't go below the line. Yeah? And that's what estimation used for. You promised to deliver, you didn't deliver. Shame on you, who's to blame? That's how estimation is used. That's the only reason for them. So if you use this one, there's no shame and blame. You say, there was 67% we're going to deliver by Christmas. We didn't deliver. Yeah, obviously it was like 20% probability we hit that. There is no shame. There's no one to blame. We told you it's going to be not 100%, 67. Yeah? And that's what I'm saying. Everything, when people want to estimate and they plan, it's not like what it's called data-driven rubbish. Nobody's data-driven. It's all driven by feeling. Because this is complex environment. Software development and other work, I don't know, maybe somewhere not like knowledge work. It's a complex environment. You cannot measure complex environment by definition. Because when you start measuring, you affect the system, people are going to adapt, people are going to change. Right? And the only purpose to measure and to sort of plan, estimate, that's so you can shame and blame people. Even people blaming themselves. They say, yeah, I wanted to do it, but that's my fault. And developers, they love this job. They really love it. They want to do it. And now they get burned out. They got burned out just because they, feel ashamed of not delivering on promises which kind of.
What's the alternative, Alex? What's the alternative to the shame and the blame?
Yeah, this one.
Yeah.
Yeah. So yeah, that's the percentage, and it's correct, and there's no way to prove it.
Yeah.
Like it doesn't matter if you yes or no.
Yeah.
Yes, it was 67%. No, it was 25%. No.
Yeah. So,
Yeah, maybe once we run it across, we'll know.
I have a Google spreadsheet, all right, where it's all programmed. If you send me a message on LinkedIn or on meetup or whatever, so on LinkedIn I'm whatever LinkedIn. Send me a message and I'll give you access, and you can put your data in, and you click the button. There's one button, Google spreadsheet, and it will give you the answer. Yeah, if you want to play with that, but it's and you can see the code. Code is very small. If you can code, like immediately, you can do it. But you need to find the functions for standard deviation and for random. Like in whatever language, you need to understand how to get a random number and how to get standard deviation. And that's all you need. And you don't need any graphs, so I only demonstrate it for visual purposes. It's going to be just numbers. You put historical data, click the button, you get answer. That's it. And you need this. So, cool.
brilliant.
Brilliant.